In this video, I will introduce the idea of binary search to speed up the process of searching for a specific target. So first of all, what exactly is binary search? Well, in its most basic form, binary search is a search algorithm that finds the position of a target value within a sorted array. So as an example, we typically see binary search being used on dictionaries where the words are sorted lexicographically. So that means the words are sorted from A to Z, right? And if the first letter of two words are the same, then sort it by the second letter, and then the third letter, and then the fourth, and so on. So when you typically use this dictionary, you might split it down the middle initially, right? So if you're looking for some word that starts with T and you split it down the middle from M, you think about whether or not the word you're looking for is on the left or right side. So if M is too small, then look at the later half on the right side. If it's too big, look at the earlier half on the left side. And if it's just right, then you're done. Okay, so next, let's look at an example of using binary search on an array. So using binary search is pretty simple, but the idea comes from the fact that we don't have to search every single element. So if we look at this array and we want to find a target value of 76, in this case, the answer would be 10 because the index of 76 is 10. And so one way we could do this is by simply using a linear search. So we could look, is this a 10? Or sorry, is this a 76? Is this 76? Is this 76? Is this 76? And then so on until we find the value that is indeed 76. Return the index, and then we're done. So this is quite simple. But what happens if we have a large list of more than 1,000 integers? Well, you're going to get a very long process, and it's going to take quite a while. But if we use an idea such as binary search to cut our pieces in half every time, then what we can do is speed up this process by a large factor. So let's look at how exactly binary search is going to work. So first, we're going to have a left and right search range. So we're going to say first, we're going to have a left, which is going to be this 0 right here, and a right search range, which is going to be the 14. So my search range is all of these values right here. And what I'm going to do is I'm going to split it down the middle. So my middle should be 7. And the value at that middle is 47. And now you ask the computer, is that 47 too big or too small? Well, in this case, it's actually too small. So we know that all the values up to 47, from 0 to 47, or from our left range to 47, is going to be too small. Since the array is sorted, we know that all the values up to that point are going to be too small. So we can eliminate all of these values. And what's going to happen is we know that our search range can be reduced now. We can reduce our search range from our left side to become the middle, the previous middle value, plus 1. And the right value, search range, will remain the same. In our second iteration, what's going to happen is my low value, or my left value, is going to be equal to 8, which is the previous mid plus 1. And my right side is still the same. So this is my entire search range now. And what's going to happen is I want to calculate the middle value. That's going to be at the index of 11. And we see that it's a 77. And what's going to happen is we ask ourselves once again, is 77 too big or too small? In this case, it's too big, right? So what's going to happen is we're going to eliminate all of this. We know that once again, since it's sorted, all the values up to that point are going to be way too big. Okay, so then what's going to happen? Well, what's going to happen is we're just going to notice that we can reduce our search range once again. So what's going to happen is my search range is going to stay on the left here, but my right is going to reduce to the middle minus 1. And so my third iteration, I'm going to say that the L, or the left, is equal to 8, but my right is equal to 10. And in this iteration, we're going to calculate the mid to be equal to 9. And that value at 9 is 64. Okay, so if we look at 64, we're going to ask ourselves, is 64 too big or too small? Well, in this case, it's too small. Everything up to that point is too small too. And what we can do is eliminate our search range to become a smaller search range like this. And now in our fourth and final iteration, we notice that L is equal to 10 and R is equal to 10. We calculate our middle value to be equal to 10, and the value at the middle is 76, our target. And so now we're done. So although that was a little longer to write down, I can assure you that that was a much more faster if the list was very long. Now, obviously, if this list is not sorted, then we cannot use this idea, since we're essentially eliminating all the values because we know all the values up to that point are too small or too big. And so that's the idea. So in order to calculate the middle value, we can simply do mid is equal to low plus high divided by 2. Or in our case, we wrote L plus R divided by 2. This will give me the middle value, but rounded down. So if we look at this list right here, 4, 5, 10, blah, 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 and our search that we're trying to look for is the value 20. What is the index of 20? Well, once again, our first search range is going to be all the values from here all the way to here. And what we're going to do is we calculate that middle value. So this is my search range. I'm going to look at the middle value. Is that middle value too big or too small? In this case, it's too big. Let's eliminate all of this and shorten our search range to just this. Right? Calculate the middle value once again, right here. Too big or too small, eliminate that. Then reduce our search range once again. Calculate the middle value, too big or too small, eliminate all that. Finally, reduce the search range once again. Now both of them are on 20. The middle value is equal to our target, and return that value. So that's essentially a summary of how binary search works. Next, let's look at a specific implementation on how we might do this recursively. So obviously we can think about the idea of binary search being recursive because it's essentially solving sub-problems for us. Since the problem can be reduced, this overall problem can be reduced to half of it, right? We can look at half of this problem. So now solve this. And in this subproblem, solve this. In this subproblem, solve this. Keep splitting in half and solve a smaller problem until we get to the final answer. And so what's going to happen is we're going to pass in a few things. We're going to pass in the target value. So right here. We're going to pass in our left. We're going to pass in our right. The array that we pass in here isn't entirely necessary to pass it into the method header, but we can do that instead. What we can do instead is make it a global variable as a static, right? So what we're going to do first is we're going to calculate that middle value for our subproblem. So let's say once again, we have this problem right here. And what we're going to do is we're going to cut it in half. Okay, we're going to look at that middle value here. And what we're going to say is if low is equal to high, and that middle value is equal to the target. So if my search range has finally been reduced to something like this, where L is here and R is here, well, let's check whether or not that value right there is equal to my target. And if it is, then return that value, and otherwise return -1, since that means that that value at the very end isn't equal to my target, and so it doesn't exist. Okay, otherwise, what we can do is we can split our subproblem into the left and right idea. So if that middle value that I calculated right here is too big, is much greater than my target, then I know that my search range needs to be reduced. I need to reduce my search range to all of this right here. Okay. However, the other case is that if it's too small, then I want to reduce my search range to the right side right here. Okay, so now that I've picked one of the sides based on those if conditions, right? Let's say it was on the right side. Well, what's going to happen on the right side is I'm going to reduce my search range and call the binary search method on that range. So mid plus 1 to high, right? So we're going to call that, and we're going to repeat this process over again. So calculate that middle value like this. Check whether or not the low is equal to high. Well, in this case, it's not, since my search range is from here to here. And what we're going to do is check whether or not the target value is bigger or smaller than the middle value. If that middle value is bigger than the target, then we know that we have to search on the left side. So let's say that that's true. So then what's going to happen is we're going to look at this range right here. And I will erase this here. So we're going to look at this target right here. Then let's say we split it in half once again, like that. We're going to check whether or not that middle value is greater than or equal to my target. And if it is, look on the right side, or the left side, sorry. And if it's smaller, then look on the right side. Let's say that that middle value is too big. All right, so if it's too big, then we look on the left side, right? So we're going to look on this side right here. And let's say that that's one element right there. So that means my low is equal to my high. And if my low is equal to my high, then there's only one value there. If I calculate my mid, there's only one value. So if that middle value is equal to my target, then I will return that. But if that middle value isn't equal to my target and there's only one element left, then I know that that element does not exist. And so this is the recursive implementation of binary search. Now let's check out the iterative implementation of binary search. So it's very similar in the idea that we need to have a low, a high, and a target, as well as an array. So what we're going to do is, once again, we'll have an array. And what we're going to do is we're going to say while the low, or while the left is smaller than the high, it will stop once the low is equal to the high, and then check whether or not that value is equal to the target. But otherwise, while the low is less than the high, let's calculate a middle value. So split this in half. And what we're going to do is see, is that middle value the target? Well, if it is, then let's just return that middle value. But otherwise, let's see if that middle value is smaller than the target. So if that middle value is too small, then I know that I need to look on the right side. And if it's too big, right, then I need to look on the left side. So let's say that middle value is too small. So I know that my target is somewhere here then. So what I'm going to do is I'm going to focus my range only to the right side. And what I'm going to do is I'm going to recalculate that middle value again. So my left is here, my right is here. I'm going to calculate that middle value by taking low plus high divided by 2. Is that middle value my target? Well, let's say in this case it's not. Then let's check the other conditions. If that value is too small, right? If that value is smaller than my target, look on the right side. So that's low is equal to mid plus 1. And otherwise, let's look on the left side. So let's say it is indeed on the left side. So that means my middle value is too big. So we're going to look on this side here, and we're going to split it in half. And so in this case, my left and right range have been reduced. And now I can just look at this half right here. Let's say that it passes the condition that that middle value is greater than my target, then that means I'm going to look on the right side. Or sorry, my left side. So that means my middle value is too big. So that means it's somewhere here. So now I'm going to focus my range here. And what's going to happen is there's only going to be only one value now. And that one value, if we check that middle value is equal to the target, then return that right now. So we're going to return that, and then essentially we're done. Now, if low is equal to high, we can just stop right there, right? We can stop right there. This will exit out of here, and it'll focus to this one right here. If it notices that the array value at the low or the high even is equal to my target, then return that low index. And otherwise, we'll return -1 to state that that value does not exist in our array. And so that's pretty much the iterative implementation of binary search. Okay, so in this video, you learned about the recursive implementation and iterative implementation, as well as the idea of binary search.